So let's look at the last ALEKS problem that you have in homework 3. You're being asked to write the solubility constant expression, the KSP, for different ionic compounds. And the only tricky part about these problems is that it doesn't provide you with the balanced equation. You have to come up with that yourself. So for the KSP, in order to be able to write it, we need to know what the products are when this compound dissociates. And this could be tricky for you depending on how much you remember from 161 and polyatomic ions and that type of stuff. You're looking for the cations and the anions. So one hint that you're going to have sometimes, not all the time, is when you've got something in parentheses, like in this particular compound, polyatomic ions are oftentimes put into parentheses. And so since we have the OH in parentheses, we are pretty safe to assume that that is a unit. That's one of the units. And the other component of this is the iron ion. So that's at least part of it. We do also have this hint where there's a 2 right here, so that tells us that we have 2 of these hydroxides. So we're getting pretty close to knowing what the KSP is for this. We know there's an iron here, and we know there's going to be this OH, and there's going to be 2 of them. The last piece of this puzzle that we need to figure out is the charges on these ions. And if you remember from way back in 161, I taught you this charge swapping trick. The number of anions is the charge on the cation, and the number of cations, which is 1, is the charge on the anions. So this is Fe2 plus and OH minus, and you better believe that ALEKS is going to want you to include the charges in this. So let's type that in. Also, make sure you're using square brackets. Fe2 plus and OH minus. Where's my minus? Oh, after all that, I forgot the exponent. Oh, and then I hit recheck without actually changing it. That's okay. I know what I did wrong. We know what I did wrong. Let's try this next one. This one looks really tricky. AgBrO3. So we don't have any parentheses to help us try to figure out what's what. And that will make it a little harder. So let me show you another trick that you have available to you. If you go to your data, so I'm over here on the right hand side. I know you can't see where I am, but the calculator and the periodic table and the data. If you click on the data and you go to the solubility of ionic compounds in water, this is not what we're actually using for this particular problem, but we can use this as a helpful tool. This table, what happened? This table that I apparently can't scroll up, or it's going to disappear. This table has cations and anions, pretty common cations and anions. And it might not have all of the cations and anions that you need, but it is going to have some of them. I've already forgot what we have here. We have AgBrO3. I'm going to go back to that table again. And I'm going to look at the cations. And if I go all the way down to the bottom of the cation list, I can see Ag plus is a cation, it's a common cation. So I know that Ag plus is a cation, and I'm going to use that information to help me solve this problem. AgBrO3. Ag plus is a common cation. So that means that the rest of this molecule is the anion, BrO3. And so my KSP is going to be Ag plus and BrO3 minus. Remember, when you're separating these, there can only be one cation and there can only be one anion. And let me try this again and see if I get it right. Ag plus square bracket and BrO capital O 3 square bracket, oops, forgot the charge, BrO minus square bracket. Looks good. Let's see if the next one is tricky. This one is pretty easy, but I'll go through this one with you too, and then I feel like you'll probably be ready to do them on your own. So Cu, Br solid in equilibrium. So one thing that you could do is go to that table that I just showed you and look for common cations and common anions and see if you can find them. If you look in resources, and I don't know exactly what's going to be on that ALEKS table, you will see that the copper ion could exist as either a +1 or a +2 ion. So you're going to have to use some problem-solving skills to figure out which one of those copper ions is actually present in this solution. But you know that you have a copper ion and you know that you have a bromine ion. If you remember from the periodic table, when we were first learning about the periodic table, I taught you this trick of counting using the periodic table as a way of predicting the charge on a lot of atoms. +1s, +2s, +3s, neutral, -3, -2, -1, neutral. And so if you remember that trick, and bromine is in this -1 column, it's, as an ion, bromide has a -1 charge, which means that copper must have a +1 charge for this to be neutral. So the Ksp for this is going to be Cu plus Br minus. Don't forget the square brackets, can't use parentheses, and don't forget your charges.